Hello. Hello, everyone.
Hello, everyone.
My name is Yiwen, and I'm product manager on the internationalization team here at Google.
My name is Fabrice Meglio, and I'm working in the Android framework team, focusing on UI and right-to-left support.
And today, we're here to give you a walkthrough of how to build your Android apps for a global audience. Now, before we start, I had a few questions for the audience. How many of you already have your app available in a language other than English? Okay, wow, that's pretty good. How many of you have your app available in more than 5 languages? That's great. What about right-to-left languages? Has anyone targeted those yet? Wow, I'm really impressed. Now, how many of you are interested in expanding to your app into a more global audience? Okay, given that you're all at this talk, you should all be raising your hand here. As you can see from this quick survey, everyone is interested in internationalizing their app, but the process of internationalization can be a bit daunting. And today, we're here to teach you some tips and show you some tools that make this process a little easier. But first, let's take a look at why it's important. Android has a lot of global momentum going for it. More than 900 million Android devices are activated worldwide, and every single day, 1.5 million new Android devices are being activated. In total, over 48 billion apps have been downloaded from the Google Play Store in over 190 countries. That's a lot of users, a lot of them international. Now, if your app were only available in English, how much of this user base do you think you've tapped into? Here's a pie chart of the internet users in the world, grouped by language. And as you can see here, English speakers make up approximately 1/4 of the world's internet user base. To reach the remaining 3/4 of the world's internet users, you're going to have to make your app global. So some of you might be wondering, what exactly does it take to make an app global? Well, on the left, I have the Google I/O app in English. And if I wanted to release the Google I/O app in all the other languages that I wanted to, I can do so in 3 simple steps: preparing, translating, and testing. Preparing involves thinking about which languages you want to expand into and updating your code so that it's internationally friendly. Translating involves finding translators well-versed in app translation, and we'll show you some tools that make this easier. And lastly is testing. After you get back your translations, you'll need to test them before you launch your app. We'll also show you some tools that make this easier. So the rest of this talk will be a deep dive on each of these 3 sections. First, you'll have to think about a strategy for language expansion. Which languages do you want to target first? There's a few ways you could do this. One is by metrics. You can look at metrics such as the top languages that are being used on the web today, or maybe metrics specific to the category your app is in, to figure out which languages make sense to expand into first. Another way is by language groups. Some language groups are easier to localize into than others. So if your app is in English, it might be a good idea to start off with other languages in Latin script, such as Spanish, French, or German. Now, we've been using a few terms here: internationalization and localization. What do those mean? Internationalization is designing an app such that it's adaptable for various languages and cultures. For example, if you were to design a layout that works across all languages and cultures, that's an example of internationalization. It's sort of like a one-size-fits-all solution for the next piece, localization. Localization is the actual adaptation of your app into a specific language and culture. For example, if you wanted to launch your app in France, you'd have to translate your UI strings into French and maybe add some local flavor, such as French holidays. That's an example of localization. Internationalization, as you might have noticed, can be a mouthful to say, so it's commonly referenced as I-18N, which simply means there's 18 letters between the I and the N in internationalization. Now, this reference also translated over to localization, which is commonly referenced as L10N. So that's it for the overview. Now we're going to take a deep dive on how to prepare your app. When your app is available in one native language, such as English, a lot of things you do in that language might not necessarily work when you try to internationalize. And now we'll give you some examples of this and teach you how to make your app so that it's more internationally friendly. The first and one of the most important things to do is to design a single flexible layout, a layout that works across all locales. A common pitfall of developers is to design a layout that's pixel perfect for the native language that they're programming in. And when they go to internationalize their app, realize that the layout starts breaking across languages. As you can see from the example here, a string of text translated from English into German and Japanese cause the text to vary a lot in both length and width. German language is a language that's commonly known for very, very long message strings. And Japanese, along with languages such as Chinese and Korean, are known for being very short. So you'll have to keep this in mind and design a layout that's really generous and works across different languages. Now, the next few pieces of our tips are a bit more technical. So let's start with a snippet of code. Say I'm building an Android app that's just a virtual Android store that sells Android dolls. And here is a method in my code that displays the number of Android dolls sold on a given date. So while this method works really well in English, it might not work well when you try to internationalize your app. Let's take a look at each of the problems and how we could fix them. One of the first problems you might encounter is the question, how do you get these strings to a translator if they're hard-coded in your code? Hard-coding strings into the application itself is a big no-no when it comes to internationalization. Not only does this make it hard for you to manage and organize your strings, it makes it nearly impossible for the translator to find them. You can either give your translator all of your code and have them dig through it, or you can manually take them out, give them to a translator, then manually put them back in for every single language. That's a lot of work. So what should you be doing instead? You should use a strings.xml file, which is located under the res/values directory of your application. In here, you can list out all of the strings that are being used in your application. And back inside your code, you can use the getString method along with r.string.name to pull that message back into your code. So now you have a strings.xml file, and you can easily send this off to a translator for translation. But what else could be wrong here? Well, to the translator, some of these strings make a lot of sense, and they'll probably know how to translate them. But what about some of the shorter strings, such as the word account? The account to a translator could mean bank account, or maybe user account. And maybe these two words can translate into different things across different languages. So in order for the translator to translate with high quality, you'll have to provide a bit more context for your strings.xml. The easiest way to do this is to provide comments above each string in your strings.xml. This comment can include information such as the background for that string, any trademarks or terminology you think the translator might not understand, or if this piece of string belongs to a restricted part of the layout, such as a button, adding in a character limit so the translator can abide by that. Other ways to provide context are to send translators screenshots of your app, or if your app is already available in Google Play, sending them a link so they can download it and try it out for themselves. So now the translator has a bit more context. What else in this piece of code can confuse them? Well, let's take a look at this piece of text, %1$D. To you, this is pretty obvious that it's a parameter. But what does it mean to a translator? It looks like absolute gibberish to them, and what if they tried to translate it? It would break your code, which would be pretty bad. What you should do here is wrap all your parameters in XLIFF placeholders. XLIFF is an international standard that helps you preserve your parameters across localization. And it works with a variety of localization tools, including the one by Google, which I'll show you later. So for all parameters in your app, or anything that you don't want translated, simply wrap them in an XLIFF G tag to preserve them in the process of translation. To provide your translators with a bit more context on what each parameter means, remember to fill out the ID and example attributes. So this code is getting progressively better. But what else could go wrong? Let's see. This piece of code works for most quantities in the English language. But what about the quantity of 1? You shouldn't be saying 1 androids were sold on, right? So in English, you can fix this pretty easily with an if-else loop in your code using a special case when it's 1 and say 1 android was sold on. But does this necessarily translate over across to other languages? Let's take a look. So fortunately, plurals vary across different languages, and there's no one-to-one mapping of plural rules across languages. Here's a few examples. In Chinese, plurals all exist in one form, and the word doll translates into wawa, no matter what the quantity is. In English, as we all know, there's 2 forms, doll for one, and for everything else, dolls. In Polish, there's 3 forms. The word doll translates into lalka if there's 1. It translates into lalki if it's a number that ends in 2 to 4, but excludes 12 to 14. And it translates into lalek for everything else. But it can get even more complicated. In a language that's specific to a region of France, Breton, there's 5 different ways you could translate a plural message, and each of these ways is very, very specific. So as you can see, plurals can get pretty complex across different languages. How do we even begin to internationalize that? Thankfully, Android can provide some support through quantity strings. For messages in your app that involve plurals, remember to wrap them inside a plurals tag. And then, for the given language that you're in, list out all the various ways you can display that message given the quantity. So in English, there's 2 ways you can display it. One way for the quantity of 1, and another way for everything else. But what happens in other languages? As you can see, the number of plural messages that you can possibly have vary across languages. So Android supports the international standard of 6 different quantity types: 0, 1, 2, few, more, and other. Some of these quantity types, such as 0 or 1, are pretty obvious in what they mean across different languages. Other quantity types, such as few or more, are a little more vague and mean different things in different languages. And there are plenty of resources online telling you, for a given language, exactly what the quantity type maps to. So when you're getting your app translated, make sure that all of your strings are in a plurals tag, and the translator will figure out which quantity types work for that language and translate those strings properly for you. Now, back inside your app, you can use the getQuantityString method and then call r.plurals.name to pull up the correct plural string. And given the quantity, Android will automatically figure out which plural string they should be using so that plurals are handled properly all throughout your app. So we're almost done with optimizations that make your code internationally friendly. There's one last thing you can do to update your code. You'll notice that our string includes a date. And as many of you know, dates are displayed in different ways across different languages. How do we fix that? Android APIs provide support here. You can use a library called Simple Date Format to configure custom date formats for your dates. And in a post-JBMR1 version, we'll provide a call called getBestDateTimeFormat, which, given the user locale, will automatically figure out the proper date format for you to display dates in. And then you can simply use string.format, give it a user locale, the format, and the date, and it'll automatically generate the right string for that given locale. Android APIs also supports internationalization of other values, such as phone numbers, decimals, currencies, and percentages. And you can use the libraries below to make these values internationally friendly. Now, the last tip is also pretty important. And to demonstrate, I'll show you an example of how Google did it wrong. Does anyone know what movie this is? OK. It's Breakfast at Tiffany's. And many of you, if you've lived in the United States and speak English, know this cultural reference. So when you go into Google Calendar to create a calendar event, it's no surprise to you when the example they provide is Breakfast at Tiffany's. You understand it, and it's cool that it's a cultural reference. But what happens when Google Calendar went international? Well, in Hindi, the string breakfast at Tiffany's literally translated over into breakfast at Tiffany's. And to Hindi users, they had absolutely no idea what this meant. Why are they getting breakfast? And who is this woman named Tiffany's? Because they didn't understand the cultural reference. So this is an example of even if you translate all of your strings correctly, that doesn't necessarily mean it's friendly for that language. So what should you be doing instead? Calendar is working on fixing this. Now in Chinese, if you try to create a calendar event, it instead says 去全聚德吃烤鸭, which simply means to get Peking Duck at a really famous Beijing restaurant. This is an example of providing cultural references so that you add local flavor for the language that you're localizing into. So when you're getting your strings translated, and if you have any part of your app that requires local flavor, such as cultural references or maybe even holidays in that country, be sure the translator knows this and doesn't translate all of those strings literally. So that's it for all the general tips and tricks for updating your code to make it internationally friendly. There's now a special set of languages that require a bit more support, right-to-left languages. And I'll let Fabrice talk more about this.
Thank you, Yiwen. So let's talk about right-to-left support. Right-to-left, or RTL, is a natural writing direction for Arabic, Persian, and Hebrew speakers. It represents roughly 300 to half a billion people. So that's quite a lot, and surely part of the next 6 billion people that will use internet and mobile devices. It's also rated to bug 5597, which has been filed in 2009, actually end of 2009, on our external bug tracking system and concerning about Arabic language support. This bug, up to a couple of weeks ago, was the most wanted bug to be fixed, and it got roughly 9,000 stars, so that's quite a lot. Let's see what we have done. So first of all, here is a screenshot of the setting apps running on Jelly Bean on a Nexus 7 with the Arabic local. If you know how to read Arabic, you will notice that the Arabic text is laid out correctly and beautifully from right to left. But the main issue here is concerning its alignment. For example, in the action bar, you can see that the text is aligned on the left instead of being aligned on the right. You can also notice on the other rows that sometimes the alignment is not correct on the left or on the right, so it's not consistent. Last but not least, UI widgets are flowing from left to right instead of flowing from right to left. So what can we do for improving the user experience for Arabic speakers? Here is the same app running on Jelly Bean MR1. And now you can see that everything flows nicely from right to left. It's total natural direction for Arabic speakers. The text is rendered beautifully from right to left, and the alignment is consistent and on the right. So what we need is actually layout mirroring and text alignment. How can we achieve that? Good news, ARTL support is built into Vue and to Vue group, so that all UI framework widgets are supporting ARTL. So I'm listing here 6 steps. The first one, 1 and 2 are compulsory, 3 and 4 are optional, and 5 and 6 are about testing your app on pre and post JDB and MR1, and also validating your work with native speakers. So let's talk about the first steps. The Android manifest first. We're introducing a new attribute for the application tag called supports RTL. And if you say support RTL equal true, it means actually that your app is willing to support RTL, and then the framework will do the necessary stuff to make it happen. But also you need to use SDK, targets SDK version 17 and more for activating those APIs. So basically 2 little change into your Android manifest. Now step 2 is about updating layout and taking care about resources. So if you remember well, when you're dealing with layout, you have left and right properties. So padding left, padding right, gravity left, gravity right. Now we are introducing start and end properties. And those properties are relative ones, and we are considering left and right as absolute ones. So going from start end to left right is a resolution process. And if you're from left to right direction, start end means left right. And if you are from right to left direction, start end means right left. So this resolution process is done automatically and is twofold. API level 17 and plus, so Jelly Bean MR1 and plus, start end or resolve and override any value you may have defined for left right. If your API level 17 and below, start end or just ignored, and everything works as before, left right are used. So for your reference, here is a full table for start end property resolution. 3 columns on the left for 17 and plus, and 3 columns on the right for 16 and below. In yellow, I have highlighted 2 columns where actually start end and left right are defined at the same time, and this is exactly what I've said before. And you can also notice that we are trying really hard to get start end properties used. Otherwise, we are just using left and right. What are the start end properties we're introducing in API level 17, so for Jelly Bean MR1? It's about padding, durables, layout margin, and a bunch of properties for relative layout. Now, the second step also is about ARTL resources. And there is a good news here. AAPT compiler is also supporting ARTL through a new modifier called -LD RTL, where LD means layout direction. So if you look at those 2 screenshots here, they are coming from an app where the developer decided to include some durables for Farsi, Arabic, and also durable depending on the density of the device. So if you are running this app on a device with Arabic local, it will pick up the durable from durable-AR- the density of the device. Then it should go to durable- the density of the device, and then to durable. But by the virtue of introducing durable-LD RTL- the density, it will hijack actually the resolution process, so that first will be resolved into durable-AR, then into durable-LD RTL, because Arabic is an RTL language, and then into durable the density, and then into durable. So that's pretty much the same thing. Okay, everything is resolved from most specific to most generic. Now you're doing step 1 and 2, and you're pretty happy when you start seeing your app running for the first time on Jelly Bean MR1. But sometimes you need to tune the result. And tuning is about layout and tuning text. So here is, on the left, a screenshot of the dialer app I was working a couple of weeks ago. And as you can see, everything flows nicely from right to left. But the main problem here is the first row of button. Actually, the dialer itself is also doing auto layout mirroring. And if you know how to read Arabic, you will see that the first row is saying 3, 2, 1. An Arabic speaker would say, no, that's incorrect, Fabrice. It should be 1, 2, 3, which is the screenshot on the right. So how can you achieve that? Well, we are introducing a new property for Vue called layout direction. And if you take the example I was talking about just before, this is a linear layout with 3 buttons, so you can say linear layout, Android layout direction equal left to right. And then everything will flow from left to right. You're forcing the layout direction. The API is pretty simple here, set layout direction and get layout direction. The most interesting part, is about actually the default value, which is set to inherit. Inherit means actually that the view doesn't know its value. It will ask its parent for getting the value. And if the parent doesn't have it, it will go up to the view chain, up to the view root. And the view root will ask the locale, what is my direction? This resolution process is done during the view measure pass. And it's done before we are calling you guys on measure, so that you're 100% sure that layout direction is resolved before we are calling you. Now, apart from layout direction, we have 2 other properties dealing with text. The first one is text direction, and the second one is text alignment, and they are using the same pattern for the API. Text direction is all about defining heuristics, so that you can define actually the overall direction for a paragraph. The default value is first strong. It means actually that the first strong Unicode char will give its directionality to the directionality of the paragraph. You can also define your own heuristics. And you can define, for example, a char count, where you will count the number of characters that are left to right and the number of characters that are right to left, and decide of the overall paragraph direction. Now let's talk a little bit about text alignment. As we have seen before, it was a little bit tricky. The default value now, if you say text alignment, is gravity. Means that, as before, you will be using gravity left, gravity right, or gravity start and gravity end. But the most interesting part here is that you can say text alignment view start or view end. That means actually that the alignment of the text will be at the beginning of the view or at the end of the view. Using text alignment like this has been really easy, and I have, as I've done the conversion of the RTL support for the setting apps, it was very useful actually. Now suppose you have some custom view. If you're dealing with gravity left and gravity right, obviously you need to go to gravity start and gravity end. If you're manipulating gravity, you need to use get absolute gravity, so that you're going from start end to left right. We have introduced a new API called onRTL property change, so that whenever layout direction, text alignment, or text direction is changing, you have a callback, and you can do whatever you want. Now, if you're redefining on measure and on layout, then you need to do something, obviously, because basically your layout was flowing from left to right, so you will need to flow it from right to left. So measurement can be changed, and layout will be changed. But the good news is that you can always use get layout direction and know the current layout direction of the view. Last but not least, if you're dealing with draw and issuing your own canvas command, then you're on your own. We are not providing anything for doing that. Now let's talk about compatibility for pre-JDB MR1. So the good news is that, as before, all new attributes are ignored from one platform level to the previous one. So all new RTL attributes will be ignored. So if you're ignoring start and end, what's left? Mostly nothing. So the trick here is actually to add start-end properties in addition to the left-right ones. So it's kind of duplication here. But you need to consider also styles for extracting actually those left-right properties into a style file and then providing your own style file for v17 or -ld-RTL. And that will fix the problem. A great example here is the Google Keep app that you may have downloaded from Google Play Store. So the Google Keep app is the first app to support RTL that has been released on Google Play. And as you can see in this screenshot, the Google Keep app is running on Jelly Bean MR1, and everything flows nicely from right to left. The text is aligned correctly and beautifully rendered. And also the nodes by themselves are using a layout, and the layout is going from right to left. Now let's talk about tool support for RTL. So as I said before, APT compiler has been modified for supporting -LD RTL resources. But you want to debug your view hierarchy, and we have introduced RTL support for hierarchy viewer. So as you can see in those two screenshots, when you're selecting a view, you can see many properties that are related to RTL: get layer direction, text alignment, text direction, and more. In a future release, we will release also RTL rules for lint, so that whenever you're dealing with RTL properties, lint will check and warn you if anything wrong. Now let's talk about a small case, which is user-generated content. So this use case is actually pretty interesting. So as you can see in the first line of this screenshot, I was formatting some phone number with an Hebrew string. And sorry, the formatting is not correct. A little bit strange. And if you know a little bit about text rendering, we are using the UBIDI algorithm, and it's doing the right stuff, because the presence of the space and the plus do some run splitting. So for having the correct rendering that you see on row number 2, you will need to use a new class called BIDI formatter. And this BIDI formatter will be released post GBMR1. It will be available in framework and support library, and you will say get instance for my context, Unicode wrap this string, which is the stuff translator would do actually by themselves by hand, injecting Unicode marks or BIDI control marks. Now let's talk about some tips and tricks. So if in your code you are using string value of an int, okay, or any number, any type, then you should remember that the format will be Latin. If you want to have actually a format corresponding to your locale, okay, you should use format with %d as the first argument. As I said before, don't forget that get layer direction is available anywhere into view. So you can say get layer direction equal layer direction RTL, and then you will know that you're in RTL context or not. I previously said that all UI framework widgets are supporting RTL. Grid layout is one of them. And grid layout is supporting RTL as relative layout, but grid layout is a better layout than relative layout. So please use grid layout. If you're dealing with locale, get layout direction from locale from TextUtil is a new API that allows you to know the direction of a locale. Funnily, this is also used when we are dealing with framework code at the top of the top of the view tree, where we are asking the direction of the locale. And then if you're dealing with databases, SQLite or any others, don't forget about formatting your query correctly. If you're using format %d, it will be formatted with the corresponding locale, and it will probably not be good for your database, and you will have SQL exceptions. So use format with locale as a first argument, and locale should be US. Last but not least, I've seen that in several apps. Be aware of numbers in table and column names. Okay, that can be also leading to the same SQL exception. So as you can see, it's pretty easy to add RTL support to an app. And Arabic, Hebrew, Persian users will be really delighted to see that. So we are looking forward to have this support from your app into Google Play. Now I would like to do a small demo, if you don't mind. So I'm switching to machine. So this is a phone put in Arabic. This is Jelly Bean MR1. And I'm going back to my machine. And I will use this awesome new tool called Android Studio. So you can see this is a manifest here. Okay, basic app created with the studio. And here, I have highlighted that for you, support HTML equal false. So I'm just running this app right now. Pushing it to the device. And here is what you see on the device. Hello world, centered with an action bar. Now I'm going back to my code, and I'm saying support equal RTL equal true. Also, please notice that the target SDK version is 17 here. I'm pushing the same app. Going to the device. And now you see that the action bar is laid out from right to left. So let's have a little bit more fun. Okay, going back here. And gravity was centered here, so I'm using now another text view using view start. Pushing the app to the device. Here it is. The text is aligned on the right. So I will pass the clicker now back to Yiwen.
Okay, great. Thanks, Fabrice. So now that's it for all of the tips and tricks in making your code internationally friendly. The next step is to get your app translated. Historically, developers have found some trouble here in that they had to search the internet for high-quality translators who are well-versed in app translation. As you might have seen in the keynote, we're launching an app translation service that makes this easier. Starting now in Developer Console, you can order translations for your strings.xml files in a few simple clicks. And you've seen this demo in the keynote already, so I won't demo it again. But what I will show you is what happens after you order a translation. So now I'm in Developer Console, and I just placed the translation earlier today for my IO app strings. And if I were to click on this button, I can check the progress of those translations. So as you can see here, I ordered my translation for 3 languages, German, Japanese, and French. And you can see translators making progress in these languages. What happens here is that translators working for the translation companies that Google is working with are busy translating our app in Google Translation Manager, a hub central for app translation. And if you were to click on one of these languages, you can see the translators' work in progress. So let me check out the German translations. So now I'm in Translation Manager, the toolkit that the translator is using to translate our app. And as you can see here, all of the strings in your strings.xml file are parsed out in a way that's easy for the translator to understand and translate. Let's take a look at a specific message and see how the translator is translating it. So you can see here, on the left is the message string itself, along with the description. And we pull that description from the comment that you leave above that message string. So it's important to leave some context for your translators through comments. And as you can see from the word remaining time, that's a placeholder. This is because this was wrapped in an XLIFF tag, and this placeholder will now be preserved across translations. Let's take a look at a few other translations. You're scrolling down, you'll see that the translator has made some progress on the translations. And then for the IO Live one, they left a comment. So we have comments in this toolkit to encourage communication between developers and translators so they can work together to produce the most high-quality translations for your app. Let's take a look at what this comment says. So here, we forgot to leave some context for the translator, and they're a little confused as to what IO Live means. Is it a trademark, and should we be translating it? And when the translator leaves a comment, I, as a developer, will get an email with that comment, so I can simply look in that email and then come into this toolkit to respond to this comment. Now, I can just tell them, no, this shouldn't be translated. Now, this translator will get an email with this response, and they'll know not to translate that string. Let's take a look at a few more examples. So at the very end is a message that's in a plural. And here, we provide plural support by offering a translator up to 6 ways to translate any strings that are listed as plurals. This allows you to provide proper plural support across a variety of languages. So that's it for the toolkit. And once the translator is done translating, they'll mark the translation as complete, and you'll be able to download it from Play Developer Console. So here, as you can see, the Japanese strings are already done, and I can download them. What happens when I download them? What I get is a strings.xml file, all set in Japanese. And all you have to do now is simply put this back into the right place in your application, and your application will be ready in Japanese. If you're using Android developer tools, you can make this process even easier, as Android developer tools will automatically download them into the correct locations in your application for you. So now, let's see. So now after this process, your app should be properly translated. If you're interested in trying this out, this is a pilot program starting in Developer Console, so be sure to sign up for the pilot program. And you can find this sign up under the APK page for a given app. So now all of your strings are translated. Are you done? Not yet. There's one more step, testing your app. The first and more important thing for you to test is the layout, making sure that your app translations didn't break your layout. In Android Studio, as you might have seen in the keynote, we're providing a really easy way to do this, where you can see the different layouts for different locales all at once and see the translations in those layouts. And if the translations are breaking, you have two options. You can either modify the layout so that they don't break, or go back and talk to your translator to get an alternate translation. That's one piece of testing you should do. For the next piece of testing, I'll start off with a story for why that's important. So here's an example of a sign that's been translated from English into Welsh. And to most users who only speak English and not Welsh, this looks like a perfectly normal, well-translated sign. The English makes sense, and you assume the Welsh down below also makes sense. But what does it actually say in Welsh? Well, it says, "I am not at the office right now. Please send over any strings to be translated." So it looks like somebody made a mistake here. What happened here was the translator was on vacation at the time these strings were sent for translation. And the people who sent the translations, who didn't speak Welsh, assumed that their vacation responder was the actual translation. So they went off and printed this sign. So what is this lesson here? The lesson is that doing just visual checks isn't enough if you don't understand that language. What you need to do is speak to native speakers of that language and make sure your app makes sense in that given language. So if you have friends or family who speak a language that you're translating your app into, that's easy. Just hand them a map and tell them to give you feedback. But what if you don't? Well, thankfully, Play Developer Console just recently launched alpha beta testing, which lets you incrementally roll out your app to a very small subset of users. And that way, you can get feedback from these users, which aren't counted towards for your review, to help you fine-tune your app before you launch it to 100% in a given language. So that's it for all of the tips and tricks and all the various tools that can help you in your journey to make your app available to a global audience. The next step is really easy. Once you've done all the preparation, all the translation, and all the testing, just upload your APK to distribute in Google Play. In Developer Console, there are settings where you can tweak the countries and languages that you want to distribute your app into. So that's it for our talk. We hope you found it useful, and we're really excited to see more apps available to a global audience in Google Play. Thank you. And if you have any questions, we have 2 minutes to answer questions now, but you can also drop by office hours later to ask us more questions.
Thank you.
Thank you. Okay, question?
Hi there. Loving the translations, but my translators are my users who are great at volunteering. Can I use that fantastic tool to let them do the translation?
Yes, that's a great question. That's something that we've thought about in the past as well. Right now, we're launching it only to professional translators in that we wanted to promote high-quality translations, but that's definitely a next step that we're going towards.
Can you give us any hints, timing?
Unfortunately, I can't promise anything right now, but we're definitely keeping that in mind.
That'd be great. And I mean, just one point, the users, they actually know the context of the app and they know what that stuff means.
Yeah, definitely, I agree. Thank you.
So if we have an app that's gone through several revisions and it's translated in several languages, and we're adding some activities, adding some new strings, how do we manage the getting just those new strings translated?
Yes, and that's also a great question. That's something that we're keeping in mind. Right now, we don't offer the support in the pilot program, but we're working very fast to offer support for that in terms of allowing you to incrementally translate the new strings in your app. So that'll be coming really soon.
Thank you.
Yep. Any other questions?
One of the things that I've found really difficult is doing the actual layouts that are agnostic of text length. One of the things that we developed at Airbnb was a text view that automatically resizes based on the character length and just had a minimum size. So I was wondering if you guys thought about offering anything like that, because that would be really useful for like getting around the pain of internationalizing actual layouts.
Yeah, that's a really good, good feedback. We'll keep that in mind. We'll talk to the Android Studio team.
Okay.
Thank you.
Is the translation tool able to handle things like XML entities, Unicode characters, or do you have to do anything special to get it to handle those?
Yes, most of those should be handled within the translation tool. So we handle almost all things that have some sort of international standard to them.
Okay, great, thank you.
Okay, I think we need to close.
Okay, I think we're out of time, but if you have more questions, you can drop by office hours. We're also passing out stickers earlier during the talk for localized Androids, as you can see on my laptop. We have about them available in 13 different languages. So if you want more of those, also drop by office hours. All right, thank you.
Thank you, bye.